hoop of radius with an angular horizontal surface when it's so initially it is rotating with the and it is given initial velocity of center is 0. So this is omega naught 0. This is our initial and let us suppose it is once again rotating in this direction and velocity of omega and its center velocity is given as v and radius in both the cases mass is given as small m. Now it is given that it is placed on a rough horizontal surface. So we are going to consider the motion of, or we can say the rotating motion about a point which is just touching the surface. For this point will be, for this rotation will be at, you can say will be having a velocity of 0 or it will be ideally at rest with respect to this motion. Therefore we are going to use conservation of angular momentum, and if we are not consider this point or take other point, then because of the frictional force the law of conservation will be not, because the frictional force is not a conservative force. A big problem in solving the equation or finding the solution rather. So this is our final. We can say with respect to point of contact, with respect to point of contact, let us suppose that is given as A, conservation of angular momentum angular momentum, we are going to have that L initial will be equal to L final, and for initial we are going to mr square omega naught is equal to, we are going to have this as omega plus r, and for a linear velocity of v, we already know this relation that v is equal to omega r. So therefore we substitute and also substitute the value of inertia. So this we get as omega r square v upon r, and plus this will be equal to mvr. R and R cancels out, so we get this as mvr plus mvr sorry, my mistake, this will be mvr. So we get this as twice mvr, and this is equal to mr square omega naught, and m cancels out and square goes with this r. So therefore we get that our v will be equal to omega naught r divided by 2. Yeah, this completes the question, or we can say, and the option number is omega naught divided C is the correct option. So option C is correct. This completes the question. Thank you.